Hello, Richard here. Welcome to part 3 of the Make Your Own CSGO C4 Prop series. And in this one, we're going to be talking about electronics. We're going to be talking about the Arduino and the keypad, the LCD panel, all the wiring, how it's all wired, what the electronics does, and all of that really good stuff. But before we get into all that, I just want to say a really big thank you to everybody that's supported the channel so far. I really appreciate everyone that's subscribed, all of the likes, all the great comments. Really value it, guys, and it makes it all really worthwhile. So I want to give a really big shout out to everyone that's helped encourage the channel so far. All of your subscribes and likes and comments are just massively appreciated. So again, thanks for that. Now, I know you're all really itching to take a look inside the device and see how it's wired. So let's go and take a look. All right, so let's take the rear panel off. This is just 6 little Phillips screws. So we'll just take these out so you can have a look inside it, see what lies within, see what horrors lurk within. Bear in mind as well that this was created as a one-off Christmas gift for someone. So I put a disclaimer in up front about the state of the wiring. You're not going to find any kind of like mil-spec wiring inside here, I'm afraid. It's all good, it all works. But there's no lacing and there's no tidiness, so you have been warned. Do not be shocked. Do not flame me in the comments telling me the wiring's horrible, so I know it is. Right, there we go. What have we got? So let's give you a little quick tour of what's inside. Now, if you've watched the previous video, if you watched part 2 and you saw all the 3D printing and the design, you're probably familiar with the layout. But here it is in the flesh, as it were. Now, what we've got inside here, in the back, we've got a little circuit board, which is made out of a Vero board. And that's a really handy way of just knocking up a one-off circuit very quickly. We'll talk more about that later. We've got a real-time clock unit. So we've got the battery here. We've got an MP3 player. Here's a little regulator. And again, we'll cover this in more depth in a minute. We'll look at a block diagram and I'll walk you through the details, but this will just get you so oriented with the layout. On the side here, we've got a little GPIO extender. I've got a 9-volt battery, so this can run off external power or battery power. And then there's a speaker. And here you can see the cut-off wires from the banana plugs. Just there. So these are the banana plugs on top. They don't go anywhere. They're just pushed in the top. And walking around the device, you'll have already seen this. We've got an Arduino nestling here with a membrane keypad above it, LCD display, and we got the missile switch, which we can turn on the Bang-O-Matic 5000 with. Love that sound. Right. Okay. So what we'll do, we'll just take a quick look at a block diagram and I'll show you how all the parts kind of relate to each other. So let's go and do that. All right. So I've done a block diagram of how everything interrelates for the CSGO prop. And before we get too much into that, I've done a webpage for part 3 and the electronics. And if you go to blog.radboogie.com, I'll leave a link in the description for this. This page has pretty much everything you need to know about the wiring on it. We've got the full parts list here, so this tells you all the components you need to get. We got the block diagram that you can refer back to, and here we go into all the various bits. There's tons of information here, and we'll probably refer back to this during the course of the video. But just be aware of that as a resource you can go to if you need extra information, if you don't get everything you need from this video. Okay, right, so let's just talk about the block diagram. So central to it all, we've got an Arduino Uno. I really like using Arduinos because they've just got tons of built-in I/O. If you compare them with something like a Raspberry Pi, which is basically a single board PC effectively, the Pi is an amazingly powerful device, but it's almost too powerful for this kind of thing. So whereas the Pi is really powerful compared with the Arduino has more I/O. So the Arduino is kind of more suited to this kind of thing. If you're just driving I/O and turning pins on and off and flashing lights and stuff, the Arduino is a really good choice for that. It's really cheap. It's really nice to program. So I always enjoy using Arduinos and I use them wherever I can. So the Arduino is sort of central to everything and everything sort of feeds into and out of the Arduino. Moving along, we've got the 4x3 keypad. That's how you can enter in the bomb codes and you can disarm the bomb and do various other functions with that. We've got a real-time clock. Because this doubles up actually as a bedside clock, we need a way of keeping the time in it. So an Arduino isn't going to be any good just for keeping time. You could write code within the Arduino to sort of keep track of what the time is loosely, but if you turn it off, you'll lose the time. So for that, we use an external a dedicated clock module called a real-time clock, or an RTC. And this basically just keeps time. It's got a big battery on it. In fact, it's almost all battery, this thing. But yeah, the real-time clock just keeps the track of the time, even when the device is powered off with no battery, no mains. It'll keep the time. And that's how we can turn this thing into a clock. We've got the 16:1 LCD display, and that's 16 characters by one line. And the one we're using is yellow. And again, you can get the spec for that on the parts list on the website. Moving around, we've got a thing called an I2C GPIO extender. One of the things with an Arduino is it has tons of I/O. It's got lots of input and output ports. It's got loads of analog I/O, and I always run out every time. Every time I do a project, I run out of I/O. And this project was no exception. I got to the point of making or wiring up the LED, the red, green flashing LED on the front, and I didn't have any more I/O pins. I'd used them all up. So the beauty is you can use a thing called an I2C GPIO extender, and I2C, or I squared C as it's often written, it's like a sort of, it's like a microcontroller USB bus, I2C. And it means that on just 2 data wires, you can string loads and loads of devices together, almost like you do with USB. You can get a USB hub and you can plug loads of things into your PC or your laptop or whatever. It's the same with I2C. And as it happens, the real-time clock is an I2C device. So we can talk to the real-time clock just over 2 wires, and we can talk to the I2C GPIO extender over 2 wires. Well, you might be wondering to yourself, well, actually, what is a GPIO extender? Well, all this is if you look at it, you've got these 8 yellow pins here. This just basically adds on an extra 8 digital I/O ports that you control over I2C. So the great thing with I2C is you only need 2 pins, no matter how many I2C devices you have. Okay, within probably reasonable limits, but for our example, we can cook up as many devices as we like. And what it means is that we can, for using 2 wires that we're already just using on the real-time clock, we just parallel onto the I2C wires for that. And then we can add an extra 8 digital I/Os. So the I2C GPIO is a general purpose input-output GPIO. That just gives us those extra ports we need to make the LED flash on and off, basically. Moving around, we've got an MP3 player. Okay, MP3 player. This is a nasty little device. It's a WTV020 device, and I just kind of bought it because it was touted as an MP3 player. It doesn't play MP3s at all. It's actually an AD4 player, so it's not an MP3 player, it's an AD4 player, and it took an inordinate amount of time to get this working. It wouldn't play, or it would play very badly, and it was really hard working out what file format to use, because I say they don't play MP3s. You put MP3s on and it'll just look at you like you're stupid. You have to convert the MP3s into WAV with a specific PCM bitness and things like that, and a specific frequency. And then you have to use a special command line application to convert the WAV files into .AD4 files. And yeah, it was just a real pain. So to be honest, if I was going to make another one of these, I wouldn't use the WTV020 device again. It was just too much hassle. However, if you want to, I've worked out all the wrinkles now, so you're home free. You can go ahead and use this, and hopefully you won't have any headaches with it. Again, all the info on that is on the web page, so we can look at that in a bit. Now, you notice as well, it's got a 3.3 volt regulator. This is something else to bear in mind, that with SD cards work on 3.3 volts, and a lot of tutorials that I found telling you how to use the WTV020, they would have it hooked up to 5 volts, and that's not a great start, really. You're just asking for trouble with that. So what I did was I put in a 3.3 volt regulator. It's actually a variable step down regulator, probably a little buck converter or something. And I built that in so I could take, basically what we do is we take 5 volts off the Arduino to power the regulator and step that down to 3.3 volts to drive the MP3 player. Okay, so what we'll do now is we'll just pop over to the web page and we'll have a bit of a look through that, and then we can talk about the actual wiring itself. Okay, so back over on the web page, and we'll just walk through some of the things we've got on here. So we've just spoken about the block diagram, and on the web page, we'll go into more detail about all the various bits and pieces. So we've already spoken about quite a lot of this stuff. So the wiring, just to sort of look like the real in-game prop, we used a floppy disk cable to wire up things like the LCD panel and the keypad. You can see that here, and that's just sort of run here from the LCD underneath the Arduino. The real-time clock, we just spoke about that. The keypad, now, if you're just following along with this as a sort of tutorial, then you don't really need to understand anything about the keypad. Later on in the web page, let me show you quickly. We got a thing called a wiring schedule, and this basically tells you which wire goes to which pin. We'll come back to that. But what it means is things like, if we go back to the keypad, you don't need to really understand the circuit diagram or the wiring. You can just copy the, pin for pin where the wires go. But if you're building your own project and you're looking at this for reference for a different kind of application or a different project, then what I've done, I'll put the pin out for the LCD pad here in a little table on the web page, because it's really not intuitive. If you look at the pins from left to right, so you've got this is pin 0, which is just not connected. And then we've got pin 1, 2, 3, 4, 5, 6, 7, 8. Pin 1 is keypad column 2. Pin 2 is keypad row 1. Pin 3 is keypad it's all over the place. So that took a bit of mucking around to sort of work out which pin goes where. But again, even with that, with the software, when we come to the software in part 4, you don't really need to worry about that. As long as you wire it up the same as we've got it here, and then you use the source code as it is, it'll all line up, and it'll know which pins to talk to. So the MP3 player. We've spoken about the MP3 player. That's all you need to know about that, really. And the GPIO extender, again, we briefly mentioned that, how we can add more IO into the device. There's a bit of a picture of it there in situ. Next thing really is making the circuit board. Now, the circuit board, as I said, it's made with Vero board. And this is just a sort of a fiber board, plain on one side, copper strips running along the other side. And what it means is you can fit components from this side and then solder them onto the other side, onto the copper side. And then wherever you want to break in the tracks, you just get a 3mm drill bit and just gouge out the copper on the track, and you can create little separate tracks. And if I show you on the web page here, scroll down, there's a photograph of the back of the board. So basically the board is somewhere we can mount components. So you imagine we've got all these components like MP3 players and 3.3 volt regulators and the real-time clock. They all need to go somewhere. So rather than sort of having to like fit little screw holes and screw them into things, we can just solder them onto a single board, and that sort of houses all the electronics that we need, really. It also provides a place where we can like bring in the ground connection and the positive supply, and we can just have sort of supply rails or connectors that we can just pull off 5 volts, 9 volts, whatever we want within the circuit. So for the board, it's pretty simple to make. You just cut it to size, and I've put a photograph of it up on the web page. So the best thing to do is really just copy this, cut the board the same size, and you can see these holes here where I've drilled out the tracks to disconnect the tracks and to isolate certain areas. Copy what you see here, pretty much. If you scroll down a bit further, there's another diagram that shows you sort of like where all the components fit, so you can see the sort of the orientation and layout of all the components. So that's where they all fit, and you can see where all the pins go and stuff. So yeah, basically copy that and you'll be good. There's a few little things to bear in mind. As I was sort of prototyping this is like a sort of a finished prototype, really, I suppose. One of the things I did was I cut a track here, and I didn't need to, so I bridged it back over with a bit of tin copper wire. So you don't need to cut this track here, and you don't need to bridge it. That's just supposed to be like that. What else have we got? If we scroll down through, yeah, the 3.3 volt regulator, there's a little bit of a trick to how that's fitted. When you look at it on the board, only these two left-hand pins here are actually all the way through the board. So the 2 pins on that side go all the way through the board, and the 2 pins on this side, they only go through the voltage regulator. And just to illustrate that, I've done a little diagram here. So you can see that the left-hand side pins go through the circuit board, whereas the right-hand ones only go through the regulator. It's just one of those little quirky things. There's no sort of clever reason for doing it. It just got the job done, and the board is held on well enough with just 2 pins anyway. So that's just how I did it. If you want to change it, go ahead. You know, you've got free reign to mod this however you like. So moving along, yeah, we've got a note there. This track doesn't need to be cut. The red and green LEDs. So we've got the red and green LED in the front, and that's actually it's hidden behind the board in the actual main prop. But you can see here a bit of a detail as to how I just put the LED in. It's held in with a little bit of hot glue, and then the current limiting resistors are just soldered straight to the LED. Nice and easy. The speaker is pretty self-explanatory. There's a couple of little plastic tabs that we would have printed in part 2 that are used then just to clamp the speaker in place. The missile switch, again, pretty straightforward, just the main power from the DC jack, and the battery comes in on one side and comes out of the other. And with the DC jack, now I did say in part 2, I said that I couldn't find where to buy it, so I gave you a diagram of what the dimensions were for the DC jack. I did actually find out where I bought it from. So if you go back to the parts list, there is a link to the actual one that I used, so you can buy the same one that I did if you want to. But I put a little diagram in here just to explain the DC jack, because the DC jack switches the battery in and out. Because we've got an internal battery, we wouldn't want to have the battery connected and powering the device at the same time you've got like the wall power in. Say wall power, it's like, you know, just 9-volt DC from a little mains adapter. But you don't want them on at the same time. So what we do here is the DC jack has a little switch inside, and it has 3 pins on the back. And one of them is a common, which is the ground that you can see on the circuit here, pin 3. Then you have the center pin of the DC jack, which is the positive, and that's pin 1 on the diagram. And then the second pin is actually like a switched ground. And what we do is we connect the battery across pin 1 and pin 2. And then when you plug in a DC jack, it actually disconnects pin 2, and the common is on pin 3. So effectively plugging in a DC jack just cuts out the battery. Really neat, really nice, works really well. So that's a little bit of detail on that if you need to know about that. And then we've got a bit about the wiring. And this is the center of it, really, the wiring schedule. Back in the day, I used to be a professional wireman. Yeah, you probably wouldn't guess from this. I used to do better work than that, honest. But when you're wiring cabinets and complicated things, you don't tend to work from a circuit diagram. Circuit diagrams are more for troubleshooters or designers or people that need to understand the actual electronics. When you're wiring something up, you just need to understand how to wire it up, not necessarily how it even works. So what we do is we use a wiring schedule, and that's literally just like a little spreadsheet. And you can see each wire has a number where you can number the wires if you wanted to. You don't have to. But the schedule just tells us where the wire comes from and where it goes to, and some comments. So here you can see a great big list of all the wires you need. So for example, wire 1 is from Arduino D0, and it will actually say D0 on the Arduino on the silk screen print. And that goes to keypad pin 7, and it goes via the floppy disk cable. And then wire 2 is from Arduino D1 to keypad pin 5, and so on. So here, literally follow along with this. This will tell you which wire goes to which pin. Connect all the pins up as described here, and that should be it. That should be all that you need. Now, if you do find any errors with this, if you find any problems, please let me know. Let us know in the comments on the video or comment on the blog. And if you find any problems, I can then update this so that the next person can benefit from it. And, we can sort of share the knowledge and, iron out any bugs that way. So, and also, as always, any questions, if you've got any questions about this, hit the comments on the video or head over to the blog site and leave a comment there. So that's really it in terms of the overview there. So what we'll do now, we'll just head back over to the device, and I'll just sort of walk you around that in a little bit more detail with any sort of final thoughts on the wiring. Okay, so looking back at the device again, let me just see if I can get you a good angle on this. A few little things to bear in mind. Now, for the most of the wiring, I've used what's called Kynar wire. The green wire, thin green wire and the thin red wire, it's called Kynar wire, and it's a solid core insulated wire. And you don't need anything very thick for this. There's hardly any current being drawn by any of this, so skinny little wires are fine like that. The thicker wires, these are the sort of the main power into the device. Again, they don't need to be very thick. This is probably over the top, really. The main reason I use thicker wires for that is that they're just thicker on the outside and they're going to be a bit more resilient. They're not going to be so prone to breaking with handling and things, and they just look better as well. Remember, it's got to look like a prop. One of the little sort of tricksy bits with this, in a way, is the way that the GPIO is powered up. The GPIO is powered on these 4 pins here. Let's see if I can show you that. So these are the sort of the power pins here. And what we do with those is we basically piggyback those off these 4 pins off the RTC. Can I get you in there? There you go. Let's have a look at that. So on here, you've got these 4 pins on the RTC, or the real-time clock. Basically, what we do is we wire these 4 pins, which is like the plus and minus and the I2C connections, and they just basically piggyback from here onto here. And those connections actually feed in on this side through these pins, but the pins sort of pass through to the other side. So we just sort of use that as a convenience, really, rather than sort of wiring the GPIO data and power pins from, you know, separate points on the board. We just piggyback them off the end of the real-time clock module there. We already mentioned about the little trim pot. So there's a little trim pot here, which is for the, there you go, let me show you that. This is for the contrast on the LCD. So you can actually put a little trim pot screwdriver in there. You can twiddle the knob and you can adjust the contrast if you need to. So here you can see we got the MP3 player. That's got a little SD card in it, so you can actually pop that out and update the soundtracks on there if you need to. So that's probably about it for the sort of internal electronics. Like I said before, the banana plugs, they're just literally pushed in from the outside through the holes, and you can just see where they come in there. See one of them in there, I believe. And the wires then go through underneath the Arduino into the device, and then we just basically cut them off and put a cable tie on to stop them so they don't pull back through. The Arduino, all the wiring to the Arduino, all the pins, all I've done for that is basically tacked the wires on underneath. You won't be able to see under there, unfortunately. I can't get you in that close. But the wires, the wires to the circuit board inside basically come out through the holes we made in the front of the device, and then they're just basically tacked underneath the pins here. So they're just literally tacked onto the bottoms of the pins for these headers where they need to go. And as with the keypad wiring, so we've got the cable here for the keypad. This basically goes underneath the board and just terminates straight to the bottom of the board. In fact, you might just be able to see a wire in there. That's the kind of thing. We're just basically tacking the wires onto the bottoms of the pins. So nothing really spectacular there. So let's see if we can get that focus for you. So that probably just about wraps it up, talking about the wiring and the electronics. Okay, so that's the wiring and electronics pretty much covered. The next part is going to be part 4, and it'll be the final part where we go through the source code and we talk all about that. Now the source code is already available on Patreon. If you want to get early access to the source code, that's available to Patreon subscribers as early access. It will be made public when I release part 4 of the video and we do the code walkthroughs and all that kind of stuff. So if you're in a hurry to get this built, then that is an option for you. And I hope that you found this video useful. I hope you found the series useful. Again, I really appreciate everyone that's subscribed and given the videos a like, and say all your comments. I read all your comments and I'll reply to them wherever I can. Really value it. Really makes my day. So as I say, I hope you enjoyed that video, and until next time, thanks for watching.